short introduction about trust and ethics in artificial intelligence beyond the scope of finance. Then we're going to do a focus on credit scoring and machine learning, so more finance. And then we'll focus on two of the main techniques in explainability. And one of them was already mentioned in the previous speech. It was SHAP. And then we'll conclude. We've all noticed that this last few years, concern has been raising about ethics and AI, whether it's about privacy, so beyond the scope of finance. It can be about privacy of your data and how your data is used. So we've done some surveys and research within Capgemini, and we see that either when it's customers or companies or people doing B2B, this is becoming a criteria when people are deciding if they want to work with you or not, or if they want to buy your product or not. So just from a reputation perspective, you should do it. And from an ethical perspective, you should also do it. To give you a first example related to credit scoring, right now there is a controversy in the US about Apple Card credit score. And I'm going to detail later, for those of you who don't know what it is, what is a credit score, but basically how you assess the credit worthiness of someone based on algorithm. And right now, this controversy that Apple Card is having in collaboration with Goldman Sachs, nothing is proved. It's just to make sure everybody is clear about it, it's just a controversy. They are being accused of having a gender bias in their model. And as of now, they haven't been able to explain why. So, or if it's true or if it's not true. That's one of the examples where explainability in your model is very important and can be very damaging for you if you have a pure black box. I'm going to go very quick on this one. The regulator is obviously also looking at this topic. In Europe, we've all heard by now about GDPR. In the field of banking, the ECB is also looking closely at explainability. And in this case, in what we're going to talk about in the specific topic of credit scoring. From a research perspective, from an R&D perspective, this is a little picture of the activity in terms of publication in the field of explainable AI. So it's really been exploding since 2015, which is a sign that this is becoming a hot topic from many sides, coming from the people, from the regulators, and research is very active on this topic. So it's a new and innovative field, which means we have by no means reached a perfect model or approach, but it's a very interesting and important topic to follow. So in the field of credit scoring, so what is credit scoring? So it's an important tool in credit lending. It's an algorithm, or as a previous speaker said, it can also be based on expert rules by human being. But I would argue that even if it's not always by very good machine learning models, usually it's a statistical model behind it, which is evaluating the credit worthiness of a customer or a company. So it can be probability of default of a customer on a consumer loan, or it can be a probability of bankruptcy, for example, on a company. It's used in many fields and in different ways in many fields. So for example, when we talk about consumer loans business is a business where you have a lot of volumes on small loans. So that's typically the kind of field where statistics and machine learning are going to work reasonably well. So you have a lot of automation in this field, and automatic decision based on algorithm. Then at the opposite side of the spectrum, you have lending for large corporates, where you have lower volumes of very big loans. There, you're not confident enough with the model to take a full decision on very large amounts. So in this case, it's just there to help you take a decision. You also use it to decide what interest rate you want your client to pay. And another big topic in the field of banking, RWA, so risk-weighted assets, particularly since the financial crisis, how much capital you need to put aside when you take a risk. One of the main inputs of these calculations are probability of defaults. A very important input for many activities. So you need a good default prediction accuracy. It's a bit beyond the scope of this presentation, but you need to consider the difficulty of implementation from an IT perspective. It's not a fun side of the story, but very often industrialization is actually the bottleneck somehow. And then you need explainability. And I'm going to take here just point three key reasons why you need explainability. First, just for good practice. When you're a risk manager and you manage a book or portfolio of loans, you just want to understand what you're doing, so you can't use a black box. Second, for customer relationship. If you say no to a customer for a loan application, You can't just say no and that's it. You need to be able to tell him why you said no. Simply because you have to. The regulator is actually asking you to. So this regulator can be, so it can be a GDPR in terms of regulation, and in the field of banking, it's also coming from the ECB. On this side, I'm going to highlight that when you do machine learning, and in this particular case of credit scoring, you usually have to find a compromise between the predictive power, accuracy of your model, complexity of your model, and the level of explainability. So it's quite easy to understand. Neural networks, it's a very complicated model. There are many variables. The dependence between all those variables are very complex. They're correlated. In terms of number of variables, it can be hundreds, thousands. So it's very powerful models. They are used in many fields, whether it's life science, computer vision, and credit scoring. Maybe not yet, but very powerful model, but very difficult to explain and to understand. Then at the other spectrum, you have linear regression. It's a bit sad because it's probably the simplest model ever, but it's probably used a lot still today in the field of credit scoring and in many other fields because it's very easy to understand for many people. But because it's very simple, it's a very simplistic modelization of the world. It also means that in terms of predictive power, it's not very good. So what we propose, and that's what Abdessamad is going to show you now, and it's that with this new field of explainable AI, the jump is possible from linear logistic regression to ensemble methods. Not to neural networks, but to ensemble methods. Just for information, we know of one large European bank that is already testing this, at least one. And Abdessamad is going to talk about two of the main methods that are used these days.
So my name is Abdessamad, and I am a data scientist at Capgemini Invent. Xavier explained that AI explainability is very important, especially in the case of credit score. And now we will see what is exactly AI explainability and what are the different methods to do that. So we all know that data scientists do magic with data. They implement algorithms to do a specific task. But these models are finally a black box for the final user, and they are even black box for data scientists. So, for example, for the case of credit scoring, if a client comes to you and asks you for a credit, and if the algorithm behind say no, you will be unable to explain to your client why you refuse them the credit. But if a data scientist implement an explainability method with a machine learning algorithm. So in this case, you will be able to say to your client, so we can't give you the credit because of, for example, your salary, or because of the credit amount does not match the purpose of your credit, and so on. So AI explainability are a new research field aiming to develop interpretability method to explain the decision of machine learning algorithm, or what you call black box. Now there are two approaches toward achieving machine learning interpretability. So the first one is a global explanation, and here we attempt to understand the high-level concepts and the reasoning by the model by looking at the feature importance, which means here we are looking what are the main contributors to the prediction of the model in the whole population. And the second approach is the local explainability, and here we're trying to explain what is the explanation for one prediction. For example, here in the case of credit score, we are looking what are the main variables that that contribute positively or negatively in the outcome. Here is a credit score. From the both definition, so we can end up with maybe with different explanation, which could be very normal. If we take the variable, the income as a variable, so it's the first variable in both approach. But if we take, for example, a duration, it's well ranked when we use local explanation, but I think duration is at the center of the list when you're using feature selection. We can't talk about AI explainability without mention the two popular methods that used in AI explainability, LIME and CHAP. So both are agnostic method, which means they could be applied to any machine learning algorithm. I will not explain the detail behind both methods, but I will maybe give you the intuition behind each one of them. So if we look, for example, to this figure, and if we suppose that the red area are bad pairs and the blue area are the good pairs, we can quickly understand that we can approximate this model by just a linear regression. In order to interpret a given point in our dataset, in the case of credit score, it could be, for example, loan applicant. So what we'll do, Lime, is we'll look for a similar loan applicants to the chosen one, and it will apply a linear regression to this population to interpret why we give a certain prediction to this instance. And because, as Xavier mentioned, that linear regression is easy to interpret. The second approach is CHAP. So CHAP is more complicated than LIME. So CHAP is based on what we call shapely value. And shapely value is a technique used in game theory. The purpose here is to compute how much each player in a collaborative game contributes to the success of this game. Which means how can we divide the payoff that we can get from the game among the player in fair way. If we take, for example, this figure, so here we have three players E and B, A, C, and if you suppose that they are playing a card game. So this technique, they are looking to the interaction between player by looking at the payoff generated by the generated payoff when some of the players are not present. One of the typical visualization that we can get using CHAP library. So is this one, and here the analogy between shapely value and CHAP is that every feature is a player in the case of shapely value, and the payoff in the game will be the prediction of the machine learning algorithm. I will mention some benefits and limits of the AI explainability. So for the benefits, we already mentioned that explainability method can unlock a black box. Which is the topic of this presentation, and we already know that one of a large bank in Europe is testing l'IGBM with CHAP in the context of loan customer credit score. The second point is that current explainability method could give to data scientists some insight, like detecting bias in the data, and even for user, for example. If we apply explainability in healthcare, so explainability can lead doctor to a new reflection to detect a disease, for example. There is some limits that we notice while working with some of our clients. So the first one, we noticed that explainability methods are very sensitive to some characteristic in the data. For example, if the data has noise or correlated variable, it will impact negatively the interpretability. The second point is if we use interpretability method, in some case, we can end up with a large number of variables. So it will be complicated for normal human to understand this explanation if it is based on more than 4 or 5 variables.
Just to conclude, one thing we forgot to mention is when you choose a model, a proprietary model for credit scoring, you need to convince the regulator. Part of our research also showed that the regulator, the ECB, is also looking at these two methods we mentioned, so LIME and CHAP. So that's an important point. To conclude on this last thought, I wanted to do some, so it's not exactly maybe a provocative few points to criticize the right to explanation, because it's a good idea, but there are some negative side effects, and it's not an easy topic. So what means explainability? We talk about explainability, the regulator talks about explainability. What does that mean? Is there a common definition? Does explainability mean the same for a credit analyst that is quantitative? Does it mean the same for a consumer loan applicant, sorry? If we are not careful about this kind of definition with the regulator, maybe we'll converge to a lowest common denominator of what means explainability, in which case we might restrain a lot innovation. Aren't we asking more from algorithm than we are asking humans? So like, again, coming back to our case of credit lending, is the credit analyst really explained to decompose bit by bit what and by a sum of components exactly what his decision was when he decided to give a loan or not. And finally, despite this point, which we need to solve and mature on with the regulator, we need ethical AI. It's not a choice. We have to go for it, and to incorporate criteria to not discriminate and to have bias in any of our models. So, thank you.